Okay, my wonderful students, I am going to try to introduce a new topic to you since we just had a test on acceleration. Now we're going to talk about force. Now I wish we could be together and we could have this like dialogue about all of this, but we can't, and so I'm just going to try to do the best I can with what I have available. So, what is a force? Now, usually when I ask this question in class, we have, I'll write like the word force on the board, and then like we'll say, okay, what's the most basic definition you can come up with for what a force is? And then usually at least someone, or maybe multiple people in each class, will say, well, it's a push or a pull. And I say, or it's when you push something, or it's when you pull something. That usually comes up in conversation. And I'd say that's about the most basic definition you could have for force. A push or pull. And I'm going to say between, I'm going to add this, between two objects. Between two objects. That's kind of an important part. We can't forget that forces actually happen between two objects. Now, moving on from there, there are two categories in which we find these forces. Two categories of forces. There are contact forces. Hey, I hope you're writing notes on this. Oh boy, I need to erase that. I don't know what happened here. Oh boy. Oh jeez. Well, forget it. Dang it. Contact. And there are also field. Oh geez. Contact and field forces. Now, what do you think contact forces are? Well, forces that happen between what? Objects that are touching. So a contact force, again, is a force between, hope you're taking note. Hope you're writing this down. You better be writing this down. Force between two objects that are touching. Oh boy. There we go. So, force that happens, a push or a pull that happens between two objects that are touching. A field force. Now, what do you think a field force would be? If contact force is between objects that are touching, then it would only make sense that a field force is between objects that are not touching. So, it is a force between two objects that are apart. They're oh, no. I need to change that. That, how should I say this? That don't have to, oh no. This is really bad. You're going to be done writing it before I even get done reading it. I mean, I'm not reading it, I'm writing. Oh my gosh. Force between two objects that don't have to touch. Now, think about this. What are some things that you can experience a force, and the objects that are exerting the forces don't have to actually touch? Like even from a distance, you can see that there is definitely a force going on. Can you think of anything there? How about magnets? That'd be an example of a field force. Static electricity, static electrical forces, static electricity, or static electrical. Oh my gosh. Static electrical. And then another major one. Another major. So magnets, static electrical. You're experiencing it right now. We all are. We can't get away from it. Gravity. Gravity is a field force. You are experiencing gravity right now because you are in Earth's gravitational field. It's called a field. That means if you climb up in a tree and you were to jump out of the tree, if you were to climb up in a tree and then jump out of the tree, oh boy. While you're falling to the ground, are you touching the earth? The answer is no. Is the earth pulling on you? Yes, that's why you fall. And so, that, in this case here, you are not in contact with the earth. You're not actually touching the earth, but the earth is exerting a gravity force on you. That makes gravity force a field force. Now, pretty soon after you fall, you're going to actually hit the earth, and when you make contact with the earth, then the earth will exert a contact force on you to stop your motion. So the earth can do both, you see. The earth can exert a gravity force on you, whether you're touching it or not. And then it can also exert a contact force on you when you are touching the earth. So magnets can also do both. I mean, they can exert a field force on something, but then they can also contact it, touch it, and exert a force on it as well. Objects that have static electrical forces, they can do the same thing. They can contact things, but then there's also electrical forces based on the charges that make up matter. So anyway, this is the main one we'll have around. Like that's going to be around on most of our scenarios. So speaking of, let me give you a scenario here. Okay, here's our first little scenario that you're going to need to jot down. This right here is a book on a table. Let's just pretend that we have, well, forget it. I was going to make it three-dimensional, but I decided not to. So this right here, that's a book. Book. So the question, this is a book sitting on a table. Table. So, a book sitting on a table. Are there any forces acting on the book? Are there any forces acting on the book? Yes, there is a force of gravity, right? Earth's gravity is pulling down on the book. Anything else? Is the table pushing on the book? Is the table in contact with the book? And so is there a force of the table that's pushing on the book? Well, yes, because if it wasn't, what would happen to the book? It'd fall to the floor. And it isn't. It's just sitting on the table. So we're going to draw what is called a force diagram. Okay, this is a force diagram. First of all, I'm going to draw a circle around my system. The book is my system. That means that's my system. And my system is the object. It can be more than one object. The object or objects that I, oh my gosh, want to investigate. Oh my my gosh, this is terrible. So that's the object or objects. Could be more than one if you lump them together. For instance, now we got to have a floor down here too, I suppose. Like the table is on the floor, and then the book is on the table. But I only care about the book right now. I only care about the book. And so I'm going to represent the book. Oh, not with black ink. I am going to represent the book as a dot. Okay? That's my system. My system is the book. I circled it to tell people, hey, I only care about the book in this case. And so I'm going to draw a force diagram. What direction is the gravity force acting on the book? I hope you know that gravity acts in the same direction on all objects, and it is toward the center of the earth. Now, toward the center of the earth, for us, is what direction? We'd probably call it down. So I draw an arrow. That arrow represents the force of gravity on the book. And here's what I'm going to do. I'm going to name it. We name our forces. Force of gravity, oh boy, on book. I didn't write the whole word gravity out. I was going to run out of space. So, force of gravity on book. That is a force that's acting on the book, and it is in a downward direction. And for force diagrams, we always draw them so that the arrows go away from the dot. So arrows go away from the dot for our force diagram. So we would not put the force arrow up here pointing at the dot. It would start at the dot and go away from the dot. That's just typically how we draw them. And is there any other force acting on the book? Well, I think you said earlier, or I said earlier, that the table is pushing on the book. If the table is not pushing on the book, then the book's going to fall to the floor. Right? If you remove the table from this scenario, then the book falls to the floor. So that means the table has to be pushing upward on the book. Now the question becomes, how much do you think it's acting? Like how big of a force is it? I can't tell if I made it the same size or not, but I'm going to tell you it's the same size. Okay? The table doesn't push any harder on the book up than what gravity pulls on the book down. We would call that balanced. Do you agree with that and understand that? Force, again, that has a name as well. Force of, oh boy, of table. Sheesh. Table. No. Yes. Force of table. On book. Oh my gosh, this is terrible. Force of table on book. I'll capitalize it because I did in the other one. Oh my gosh. There we go. Force of table on book. That's the other force that's acting on our book. So we have a force of gravity on book. We have a force of table on book. And I'm telling you that they're balanced. They're the same amount, but in opposite directions. If the force of the table was bigger, then the book would be going up. Right? If the force of gravity was bigger than the force of the table, then what would the book be doing? It'd be falling. So the book is neither shooting up off the table, nor is it falling to the floor. So I'm going to say that these two are the same amount. We say that they are balanced. Okay? And that's what we call it. We call it balanced forces. Balanced force is balanced forces. Okay? Now, there are some rules here. Okay? We have rules to how force diagrams are constructed. Okay? Notice there's arrows. Well, first of all, there's a dot. The dot represents our system. We have arrows that represent the forces. And the length of the arrows indicate how strong or weak the force is. If the force is really strong, then we'll make it a long arrow. If it's kind of weak, then we'll make it a short arrow. All right? It has an arrow point on it that tells us what direction the force is acting. So not only do we have a length to tell us how big the force is, we have a point to our arrow which tells us the direction. So it's kind of like velocity. Remember the velocity arrows in our motion maps? The length of the arrow told us how fast and which way it was pointed, told us which direction the travel was. It's the same with force diagrams. All right, our arrows have two meanings. And we name our forces like this. It's called agent-object. Agent-object. All right? The agent of the force is the table. That means the table is producing the force, and the book is receiving the force. That's the object. That's the object that's getting pushed. Agent is the table pushing. Object is the book itself. So let me do this in red ink here. So the table is the agent. And the book is the object. Now, question here with the name of this force. What is the agent of this force? You might look at that and say, well, it's gravity, because it's the force of gravity. Well, here's a more specific question. What physical thing is actually producing the gravity force on the book? I hope you're thinking that it's the Earth. So technically, for this, the Earth is the agent. We don't necessarily put it in the name, though. We don't say force of Earth's gravity on book or force of Earth on book. We call it gravity because it's a specific kind of force that we're talking about. And we need to know that the force of gravity is always going to be coming from the Earth. The Earth is the thing that produces the gravity force that we are all experiencing. Okay? So we don't call it Earth, even though Earth is the agent. I hope that makes sense. The Earth is the agent of the force of gravity on the book. Book is the object. It's what's receiving the force, but Earth is producing the gravity force. Okay? Now, I'm going to go to another slide here and write out some rules for force diagrams, and so you need to write this down, and then we'll finally be done. Oh my gosh. This is taking forever, I'm sorry. So, rules. Oh my gosh, it's a pointer still. Rules for force diagrams. Wow, this writing is terrible. All right, rules for force diagrams. Number 1. System is a dot. Make your system a dot. All right. 2. Use arrows for forces. 3. Use agent, object, naming. Agent, object, naming. 4. Oh my gosh, I forget what 4 is. Hold on. I got to think for a second. Ah, yes. Decide if the diagram shows balance or unbalanced forces. There we go. So there's our rules, okay? So when you sketch a force diagram, you got to keep those things in mind. Now, there will be another video coming. I'm going to post this one, and then you're going to need to watch this, take notes on it, and then I will show another video that will be like a demonstration. It won't be a whiteboard video. It'll actually be me doing some things, showing you like some scenarios that I would show you in class, but we're not there, so I have to do it with a video, and then you will draw some you will draw some things on your paper, like what's happening. You will sketch like a picture of what's happening, and then you will sketch force diagrams, and then motion maps and all that kind of stuff. So that'll be coming soon. But for now, make sure you get your notes written down for this video. All right. I hope you did well in the test. As of right now, some of you still haven't even taken the test. In terms of me recording this video right now, some of you have still not even taken the test. It would be nice if you would actually watch, like, pay attention to classroom and see what's actually going on so that you know what your responsibilities are. Anyway, for those of you taking care of everything, fantastic. Thank you. You've been wonderful. All right, anyway, I'll quit talking. Video's over. Write all this down. If you forgot something, go back and look at it. See ya.